Welcome to Signals and System subject classes. Now we are in the third chapter, that is continuous time Fourier series. In previous classes, the Fourier series representation and Fourier series coefficient has been discussed, and properties of the Fourier series also covered in the previous classes. Here in this class, I am going to explain finding the Fourier series coefficient for the given periodic signal. Already we have derived the formula for the given this periodic signal, but here I want to show the another method. It's very useful for the competitive examination. So this is the periodic signal rectangular train, rectangular pulse train. You know that already the formula also that is derived in the previous classes. So this is the signal. So this is a rectangular pulse train. So this is a rectangular pulse. We are assuming this is g of t here, g of t. So it is from the minus t1 to the plus t1. So it's a time period. So this is a time period, is it? From the here to here, it is repeating. So this is a t by 2 minus t by 2 minus t. So it's magnitude equal to 1, is it? So what is the Fourier series coefficient of the g of t? We know that Fourier series coefficient for this one already it has been derived, that equal to 2 into sin k omega naught into t1 by k omega naught into t. So this is the Fourier series coefficient. It's Fourier series coefficient formula. Now, so this is a g of t. So this is the one method already it has been discussed in the previous classes, is it? So with the help of properties of the Fourier series also, we can solve this Fourier series coefficient of the g of t. For that, here I am going to draw. So the g of t, now I am going to differentiate the g of t. After derivation of the g of t, so what will happen? So this is a rising, this is falling down, is it? So after derivation, you will get impulse signal upside, and here the impulse signal in downside, is it? So next I am drawing the derivation of the g of t. So at the minus t1, It is rising, is it? So rising. So this is the one impulse. So this is the impulse falling, is it? So again, so this is the x of t, q of t. I'm assuming this is q of t. So this q of t is nothing but d by dt of g of t. So these are the, so this is the capital T, is it? So minus T1. So from here to here, the time period equal to T, is it? And here to here, this is the one time period. So here, so this Q of T, it is having two impulse trains, periodic impulse trains, is it? So here, so this is 0 and T minus T. So this is a x of T, is it? So this x of T is the impulse train. So this is x of t, it is the impulse train, like sigma del of t minus n into t. So n from minus infinity to plus infinity, is it? So its Fourier series coefficient ak equal to 1 by t. That's you know very well, is it? It's Fourier series coefficient. Now, so I'm assuming this Fourier series coefficient of the q of t. So this q of t Fourier series coefficient equal to, that equal to bk, is it? Bk. Now, so this q of t, it is having two impulse train, is it? So this is from here to here one time period, and this from here to here, this is one time period equal to capital T. So this is this impulse train, it is shifted to the left side compared to this. So this is here writing here. This is, I'm writing this is, assume this is q1 of t function, q1 of t signal. Then the q1 of t. So this is q1 of t signal. So the q1 of t, that equal to x of t minus t1, is it? So this signal, I'm assuming this signal equal to Q2 of t. So that Q2 of t equal to, sorry, this is advanced signal. So this is t plus t naught, t1. So this one is x of, so delayed signal, is it? X of t minus t1, is it? T minus t1. T minus t1, but magnitude equal to minus, is it? So it is showing the downside, is it? So this bk, is it? So bk equal to sum of the two Fourier series coefficient, is it? So first, so the bk equal to, so bk equal to this Fourier series coefficient, is it? So already we know that x of the Fourier series coefficient equal to 1 by t. So advanced x plus t naught. So x plus t naught. You know that this x of t, so Fourier series coefficient equal to, its Fourier series coefficient equal to, that is ak, that equal to 1 by t. So x of t plus t1. So this is, we are assuming q1 of t, is it? This q1 of t, its Fourier series coefficient equal to, so advanced. So this advanced signal. So this is advanced signal. So advanced, you know that advanced signal e power e power jk omega naught into t1, is it? Next q2. So q2 of t, so that equal to delayed signal x of t minus t, it's a t1. So that equal to so Fourier series ak into e power minus jk omega naught into t1, is it? So here omega naught equal to 2 pi by the time period equal to t. So every signal q of g of t time period equal to capital T, the q of t time period equal to capital T, and the x of t time period also capital T, is it? Now, so this b of k, so the q of t, its Fourier series coefficient equal to, so Fourier series coefficient equal to, so bk, that equal to sum of the q1 and q2, is it? The q1 of t Fourier series coefficient equal to ak into e power jk omega naught into t1, and here the q of t equal to q1 of t minus q1 of t, is it? So this, sorry, q of t equal to q1 of t minus q2 of t. This is q2 having the negative, is it? So for the, because of the negative, here also we will get the negative, is it? So ak into e power minus jk k omega naught into t1, is it? So ak common. So we know that e power j theta minus e power minus j theta, e power jk omega naught t1 minus e power jk omega naught t1. So here just 2j. So multiplying, so 2j by 2j, is it? So 2j. So this, it becomes a sine theta, is it? So ak equal to 1 by t, is it? So 1 by t and 2j. So 2j, so 2j into sine of k into omega naught into t1, is it? So this is equal to bk only, is it? So the q of t, g of t, its Fourier series coefficient equal to, we are assuming, so its Fourier series coefficient equal to ck, is it? So what is the relation between ck and bk? So this q of t, so q of t is a differentiation, is it? Then, so bk, so q of t Fourier series coefficient equal to bk, so that equal to jk omega naught into, so differentiation. So differentiation jk omega naught is multiplied, is it? So g of t Fourier series coefficient equal to ck. Now we have to find the ck, is it? Ck, that equal to 1 by jk omega naught into bk. So the bk equal to, here the bk equal to 2j by t sine of k omega naught into t1, is it? So this j gets cancelled, is it? So the overall ck equal to 2 sine k omega naught t1 by k omega naught into t, is it? So this is the g of t Fourier series coefficient formula. So this Fourier series coefficient of this g of t, it is derived from the impulse train, is it? So already it has been discussed in the previous classes that I'll show you. So here, see, so this is the impulse train, sorry, rectangular pulse train. So this rectangular pulse train equal to AK equal to 2 sine k omega naught T1 by k omega naught T, is it? So the same thing. So 15th one, sorry. So this is about rectangular pulse train, is it? Rectangular pulse period signal Fourier series coefficient. It is derived from the. So in examination, if we asked about Fourier coefficient of this one, then directly we can write in terms of the GFT. Is it? Simple thing. Also already we know that. So this is the sum of the two impulse train. Is it? Next problem, last problem in this chapter. So that is here the last problem. Some information given for the signal period signal x of t. So we are given the following facts about the signal x of t. Following facts about a signal. Is it? This is x of t signal. So five points are given. The first one is the first point, first fact, that is x of t. The x of t is a real signal. The second point fact is that x of t is a periodic with time period 4 is 4 is coefficient equal to ak. So x of t is periodic with period t equal to 4 and it has Fourier series coefficient. So Fourier series coefficient that equal to ak, is it? The third one, so ak value is given, so ak equal 0 for mod k greater than 1. So the AK shouldn't have the magnitude after the 1 for the positive and negative, is it? So it may have the value for the at 0, at k equal to minus 1, k equal to 1. That is the information. The fourth fact, the signal with the Fourier coefficient, the signal with Fourier series coefficient Fourier series coefficients. So BK, this is another signal. So it is another signal for coefficient equal to BK. So it is related to the AK that equal to e power minus jk pi by 2. Is it? So so the time shifting. So this is delayed signal. Is it? Into a minus k is odd. Is it? This is odd. The BK is the odd signal. Is it? So you should know the Fourier coefficient for the real and odd. The fifth one is the power is given, average power is given. So you know that the time period is equal to 1 by 4. So integral within the one time period, this is partial relation, is it? So mod of x of t square into dt that equal to 1 by 2. Then find out bk. What is a bk? So this is the question, is it? So we have to find the bk exactly values, bk Fourier series coefficient. Here the bk is given in terms of the ak, is it? So now, so here from the facts, we understood that bk. So this is a signal. So it is a real and odd. So real and odd Fourier coefficient must be purely imaginary. This is the property. Already it has been discussed in the properties topic, is it? So it should have the magnitude from the minus k equal to -1, k equal to 1. So that is the concept, is it? So so first of all, we have to find out the signal in terms of the x of t, is it? So for that, for that, Fourier series representation. So Fourier series representation. So x of t, x of t is a Fourier series representation that equal to ak into e power jk. So omega naught equal to 2 pi by 4, that equal to pi by 2, is it? So angular frequency equal to pi by 2, is it? K pi by 2 into t, into t. Now we have to find the signal corresponding to this bk, is it? So for that, so here this k equal to minus infinity to plus infinity, is it? So k equal to say minus infinity to plus infinity. So I'm finding the signal corresponding this Fourier series coefficient. So substitute that bk value, the bk value equal to a minus k into e power minus jk pi by 2. So this whole equal to bk is into e power jk pi by 2 into t, is it? So this is different, is it? So that equals so sigma. So sigma k equal to minus into plus infinity a minus k. So both are here, and so a plus a to the power of m into a to the power of n, that equal to a to the power of m plus n, is it? So e power j into, yes, just k pi by 2 is a common. So k pi by 2. So k pi by 2. Here I'm writing t minus 1, is it? T minus 1. In small modification, so sigma a minus k, so e power j into k pi by 2 into t minus 1, is it? So k from minus into plus infinity, is it? Here, so here this is universal, so it's a basic our reference signal. So the reference signal must be here, the reference signal having the a plus k, is it? So I want to change. So if I change the some sign in AK, so here I'm changing the sign. So I'm taking minus k in place of the minus k. Then automatically k must be minus, is it? So that minus, I'm taking this minus. I'm taking here, is it? Minus of t minus 1, is it? So compare this sigma and ak e power jk pi by 2 into something t. So minus t minus of t minus 1, it is the place of the t, is it? Then automatically we can replace. So that just write x of minus of t minus 1, is it? So that equal to x of minus t plus 1, is it? So this is a signal corresponding this pk, is it? Here this is a partial relation. So this x of t is a signal its Fourier equation ak. The another signal x of minus t plus 1, it is also periodic signal having the time period equal to 4, is it? So we can also apply same. So even though changing in the transformation, like time shifting and time reversal also, but there is no change in the power, is it? So since you should write since time reversal and time shifting operation, this operation cannot change the average power. Cannot change the average power per period, per period. So here we can write 1 by 4 integral of t mod of x of minus t plus 1 mod square into dt, that equal to 1 by 2. So that is called partial relation. Here I am writing that equal to mod of bk square from k minus infinity to plus infinity, is it? So we know that bk here having the value for the k equal to minus 1 and k equal to 1, is it? So that equal to bk mod of bk square plus mod of b minus k, is it? So any complex number, the mod of bk is equal to mod of b minus k. Already it has been discussed in the property, is it? That conjugate symmetry property, is it? In conjugate symmetry, is it? So both are same. So here I'm writing. So here I'm writing. So this 1 by 2. So this 1 by 2, that equal to 2 into bk square. So bk. So mod of bk is it? So mod of bk, that equal to 1 by 2, is it? 1 by 2. Already you know that so this bk is a odd, is it? Sorry, the signal is a odd, then bk must be complex conjugate, is it? Complex conjugate. Then we can directly write this is a magnitude. So mod of bk, it is a magnitude. So purely imaginary. So then b minus 1, that equal to minus j by 2 and b1, that equal to plus j by 2, is it? So here you can write in complete so j by 2 at k equal to 1 minus j by 2 k equal to minus 1 0 k not equal to 1 or minus 1. So this is the case. This is the Fourier series coefficient bk from the x of t. It is very useful. Those are preparing for the engineering service examination, and also everyone, anybody preparing for the any government sector jobs or gate or anything, power sector, Transco and Genco in Telangana state, in AP. So in upcoming examination also it is very very useful. So everyone has to learn the subject very conceptually. Then you will get the job. Is it? Don't miss this concept. It looked like a very difficult practicing in number of time, numerous time. You will feel it is very comfortable. It is very easy. Is it? In next class, we will discuss previous year questions. After that, we go for the revision class. Is it? So, thank you.